Myself, Dr. K. Viswanath Allamraju, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today we are going to discuss about the velocity analysis by using Instantaneous Center method. In another way, it is also known as I-center method. In previous sessions, we have studied velocity analysis by using relative velocity method. We have solved the problems on slider crank mechanism, 4-bar chain mechanism, and other types of mechanisms. So here relative velocity method can be applicable for doing velocity analysis and also acceleration analysis of various mechanisms. Now in this session we are going to study another method of velocity analysis, that is I-center method, that is Instantaneous Center method. What is I-center? If you understand the figure, I-center is the center about which the body rotates. Consider this figure. There are two bodies are there, P body and Q body. There are two bodies. So having the P is having a non-linear relative motion to another plane body, that is Q. At any instant, the linear velocities of 2 points A and B on the body P are, what are the linear velocities are? VA and VB. Having directions which is shown in figure. If you draw a line perpendicular to the direction of the velocity VA and VB, and those two points velocities intersects at one point, that point is known as I point. So here we are here, the body, it is imagined that it is about center I. The point VA at A is rotating. Similarly, the point B is also rotating about I. It is the common point. So if the intersection of two lines at I, the body P will be rotating, about this point I at this instant. This point I is known as instantaneous center or instantaneous center of velocity, or simply known as I-center. Now let us again, this I-center of rotation of the body P. Here when body P, this is I is the I-center of rotation of body P with respect to or in relation to the body Q. So this property is true only for an instant, and a new point will become the instantaneous center at the next instant. This is at this instant. What is it at this instant? When point A and point B having direction of velocities are V and VB, at this particular direction of the velocities, the instantaneous center is I. If you see in the figure A, point A having the direction of velocity in this direction VA, and point B is also having direction of velocity VB in particular direction. The instantaneous, the I-center of P in relation to Q is outside the body P. Whereas in this figure, if you see, the I-center is within the body, is on the body P, and it is not on the Q. So the instantaneous at this particular instant, if you see the figure, observe the figure A, it is outside the body P. If you observe the figure at 2.31, it is on the body P. So at a different instance, the eye center will be varied. It is not necessary the eye center should be on the body, particular bodies. No. It can be also be outside the bodies, outside the both bodies also. If you observe here in this figure 2.32b, the direction of velocities are point A and point B, both are parallel. So where is the eye center? The eye center is at infinity. About eye center infinity, the body A, the body P and Q are rotating. So this is the meaning of eye centers. The conclusion in this slide is that eye center not only on the bodies, it can also be outside of the bodies also, even at infinity also. So this case comes infinity in the case of slider crank mechanism. If we see the slider crank mechanism, in the case of slider crank mechanism, the slider moves linearly. What is the eye center of this slider? The eye center of this slider is at infinity. Okay. Why? Because the direction of the velocity of the point A, VA, is parallel. So it is in horizontal, having 0 degree. So in that case, the eye center is at infinity. Whereas the fixed link 1, suppose and rotating link crank 2, the 1 and 2, the 2 is rotating with respect to the another link, that is fixed link 1. So the eye center will be I12, where it is located at this joint. So thus, when the eye center one link is rotating, means we'll assume that another link remains fixed, in vice versa. Here, so these are the different, in this understand this figure, eye center is that here in this figure, if you understand, there are 3 bodies are there, P, Q and R. If you draw a perpendiculars, in case the perpendiculars to VA and VB at A and B, that we have already covered in the 2.32A and 2.32B figures. So eye center is outside the body in this figure and it is at infinity. But as the body P rotates about I at the instant, and the velocity of any point on the body is proportional to the distance to the point from I. The velocity of the point I itself would be 0, that is, the distance being 0. So this implies that the 2 bodies P and Q are relatively at rest, and there is no relative motion between the 2 at the eye center. So if you understand the figure 2.33, there are P, Q, R, there are 3 bodies are there. Now imagine that the body P, the body Q is also in motion relative to third body R. Then the motion of the point I relative to the third body would be the same, whether this point I consider his body is on the body P or Q. So here it is the meaning that when the body is here, as the body P rotates about the point I at the instant, and the velocity of any point on the body is proportional to the distance of the point from I. What is that meaning here? The meaning is that suppose the body P is rotating some velocity. What is the VA equal to? Velocity of VA equal to, this body is rotating with omega P velocity. Omega P times distance from A to I. and VB equal to, or VP here mentioned, VB equal to omega B times distance from B to I. This is the meaning of mentioning. That is, the relative velocity is in proportional to the distance of the particular point to the eye center. Now, how to notate? What is the notation of this eye center? Eye center, once again, very simple definition mentioned here. An eye center is a center of rotation of a moving body relative to another body. Here, relative to another body means that another body remains, we assume for the time being, it is remains fixed. If a body P is in motion, then relative to another body, that is we assume as a Q, fixed body, the center of rotation of eye center may be named as PQ. Okay. In case of relative motions, the body Q can also be measured to rotate relative to the body P. Then, how to represent the notation? That is QP. The eye center of rotation can be named as QP. PQ means eye center of rotation of the P in relation to the Q. QP means rotation of the Q in relation to P. P remains fixed. Thus, in that manner, we will notate the eye centers. So, this shows what is the meaning of this. The eye center of two bodies, P and Q, in relative motion can be named either PQ or QP. The same thing, but in general, what is the thumb rule? The thumb rule is that we will in ascending order will follow. In ascending order means PQ, but not QP. We will not follow QP because in ascending order we will follow. That is, we will follow suppose 1, 3, 3, 5, okay, like that. ED, in that manner, ABCD, no, DE, EF. In that ascending order direction, we will follow the notations of eye center. Now, what is number of eye centers? The number of eye centers, eye center can be defined, eye center can be observed only when two links rotates each other. So, for two bodies having relative motion between them, there is an eye center. Thus, in a mechanism, the number of eye centers will be equal to possible pairs of bodies or links. So, where N is, capital N is number of eye centers and small n is number of bodies or links. The formula number of eye center equal to n into n minus 1 by 2. Suppose if there are 4 links are there, if for 4 link mechanism, for a 4 bar mechanism, for 4 bar mechanism, what is number of eye centers are? Number of eye centers for 4 bar mechanism, 4 into 4 minus 1 by 2, that is 6. The number of eye centers for 4 bar mechanism is 6. The number of eye centers for 6 bar mechanism, 6 bar mechanism, that is 6 into 6 minus 1, 5 by 2, that is 15. Okay. And if you want to observe how 5 bar mechanism, that is 5 into 4 by 2 is 10. So, if you understand 6, 10, 15, that is for 4 bar, 5 bar and 6 bar mechanism. So, there is no linearity relationship in output of this number of links. Okay. So, the range between 10 and 6 or 4, 10 to 15 or 5. You can go for 7 bar mechanism. What is 7 bar mechanism? Number of links are 7 into 6 by 2. That is 21. So, it is varying 4 here and 6. Like that it is, the range is increasing linearly. Now, this is the formula for number of eye centers. That is n equal to number of eye centers equal to n into n minus 1 by 2. Very important. Next, in order to define the location of eye centers, or in order to find out the different types of eye centers, there is a theorem. That theorem is known as Arnold-Kenneths theorem. This Arnold and Kenneths, there are two scientists. One is German, another one is another country person, another country scientist. It is coincidental that both have defined the same theorem, proposed the same theorem, but both it is validated. That's why this theorem combinedly they have given, credited to both the scientists. That's why it is called Arnold-Kenneths theorem. So this Arnold-Kenneths theorem, or only Kenneths theorem, it shows what is location of eye centers. Suppose when three bodies are rotating each other, let me read. There are three plane bodies are there. The three plane bodies P, Q and R. And R being in the P and Q are movable, R is being fixed, a fixed body. When P and Q are rotating, P is rotating about the center PR and Q is rotating about the center QR. This PR and QR, their direction of velocities are here VP and VQ. Okay, both are rotating. Now, the PR is the eye center bodies of P and R, and whereas QR is the eye center of bodies of Q and R. QR is the eye center of bodies Q and R. Assume that the eye center of bodies P and Q at the point PQ as shown in figure. Okay, P and Q are having the bodies at PQ. Now, if the point PQ is considered on the body P, the velocity vector VP is perpendicular to the line joining PQ and PR. This is the vector. And if the point PQ is on the body Q, its velocity vector is PQ and QR. This is the velocity vector. Now, what is the meaning here? You'll understand. Very important sentence here. This is the bridge sentence and this is the theorem sentence in this. The meaning is that it is found that the two velocities of the eye center PQ are in different directions, which is impossible. But what it should be in the same direction. So the eye center of the bodies P and Q cannot be at the assumed position PQ. Where it should be? It should be on a straight line joining PR and QR. That is the point. So where it should be? Therefore, eye center of the bodies P and Q cannot be at the assumed position PQ. So the velocities VP and VQ of the eye center will be same only if the center lies on the line joining PR and QR. If PQ is on this, then both the bodies are having same velocity. So what is this meaning is that we are speaking about negatively. We assume that when PQ is the eye center, okay, suppose PQ is the body on P, the eye center becomes what? If we join the perpendicular line, it will be on PR. And if PQ is the point, eye center is on body Q, then it should be on PR and QR line. But what is happening? It should not be. When two bodies are rotating, they should be a common eye center. So where it should be? It should be on a straight line. Now, what is that meaning? If three plane bodies are having relative motion among themselves, their eye center must lie on a which line? Straight line. This theorem is known as Kennedy's theorem. This portion is theorem portion. Okay, this portion is the theorem portion. This remaining thing is, this portion is explanation of the figure or description of the figure shown, that is 2.34. This is the validation statements. Okay, why it is impossible? Having a different directions. If it is a common eye center, means there will be a same direction, okay, which is impossible here. If it is in different direction, that's why it is impossible. The two velocities of the eye center PQ are in different direction, which is impossible. Okay, VP, if it is in PQ is on body P, the direction of the velocity is VP. If eye center is on PQ is on Q, it is in different direction of velocity. It should not be. The eye center, the direction of the eye center should have the same for both the bodies. So where it will be the same? If it is on a straight line, the direction of the eye center will be remains the same. That is Kennedy's theorem. The Kennedy's theorem, again, very simple. If three plane bodies have relative motion among themselves, their common eye center, must lie on a straight line. This is known as Kennedy's theorem or Arnold-Kennedy's theorem. Now, this is the Kennedy's theorem. Now, how to locate the eye centers? There are various methods are there to locate the eye centers. So, before going to locating the eye centers, there are various types of eye centers are there. That is, what is the various types of eye center? Number one, fixed eye center. Another two, permanent eye center. And third one is neither permanent nor fixed eye centers. Consider here, there is a 4-bar mechanism. There is a link 1, link 2, 3 and 4. Link 1, 2, 3 and 4. So what is the number of this 4-bar mechanism? The number of eye centers are, total number of eye centers equal to n into n minus 1 by 2. What is it? N equal to 4. 4 into 4 minus 1, 3 by 2. That is 6. Number of eye centers are 6. What are the types of eye centers? Just now I discussed, but we will find out what is the notation of eye centers also. There are various methods are there. Now, the center of rotation of 2 relative to 1 is at A, that is 1, 2, for the links 1 and 2. And also the location of A is not going to change in spite of rotation of the link 2 with respect to link 1. This eye center is referred as fixed eye center. This 1, 2 is fixed eye centers. Fixed eye center. Similarly, link 4 is rotating with respect to link 1. 4 is rotating with respect to link 1. This is 1, 4. This 1, 4 is also referred as the fixed eye center. Okay, 1, 4 also. Now coming to eye center 2 and 3. This is another eye center. 3 and 4 is also another eye center. This is 2 and 3. Okay, remains same in spite of rotation of link 2 and 4. So these eye centers are permanent but not fixed. So these eye centers are known as permanent eye centers. Now this is another eye center. This is 2, 4 and 1, 3. These two eye centers neither fixed nor permanent eye centers. But these two eye centers, 2, 4, 1, 3, are found by using Kenneths theorem. Okay, Kenneths theorem. We'll learn, we'll find out how it is to be found. So there are various methods are there. What are the methods are? How we have located eye center 1, 3. First, by using Kenneths theorem. First, consider 3 links. What are the links are? Links are there. 1, 2, 1, 3. Links 1 to 3. We consider 3 links 1 to 3. One more link, that is 2, has been added to links 1 and 3 with the condition that the eye center 1, 2 and 2, 3 are already known. And the third eye center 1, 3 to be located. That's what we are going to locate, the 1, 3 eye center. Now, as 3 links 1, 2 and 3 have relative motions among themselves, their eye centers lie on a straight line. That is the Kenneths theorem. When 3 plane bodies are having relative motion among themselves, their eye center must lie on a straight line. So that's why we have to keep it such a way that it should be on a straight line. Now, how to do it? The eye center, if you want to locate the point, we need 2 coordinates. Then only you can find out both x and y. Here we need location. Eye center 1, 3 lies on line joining 1, 2 and 2, 3. That's what we joined the line 1, 3. 1, 2, 2, 3 we join. Okay. There is one more is there, that is 1, 4, 3. Now similarly consider the links 1, 4, 3. In that 1, 4, 3, 1, 4 and 4, 3, if we extend, what will happen? 1, 4 and 3, 4 or 4, 3 and 1, 3 will come out. Then you extend the line 1, 4 and 3, 4. You extend this line, you extend these two. It lies where it is. That location of the point is 1, 3. I1, 3. Okay. That is the I1, 3 location. Therefore, eye center 1, 3 lies on the line joining 1, 4 and 3, 4. That is DC. The intersecting of the line joining 1, 2 and 2, 3 with the line joining of 1, 4 and 3, 4 produces eye center 1, 3. Similarly, eye center 2, 4. How to locate the eye center 2, 4? 2, 4. In that 2, 4, there are one more combination, 2, 1, 4 and 2, 3, 4. Then it becomes what? In that also total it comes as a 4 bar. All 4 links are combined. So 2, 1 and 1, 4 you extend. 2, 1 eye center I2, 1 or I1, 2 extension of I1, 2 and I2, 4 you extend. Then it becomes one straight line, that is I2, 4 straight line. I1, 2 and I1, 2 and I1, 4. I1, 2 and I1, 4. Then I2, 4. In that another one, I2, 3 and I3, 4. If you extend, then I2, 4. These both the lines intersect at a point. That center, that point is known as, that is eye center 2, 4. Let us see how the eye center came out. 2, 4. I1, 2 and I1, 4 is extended. Another one, 2, 3 and 3, 4 extended. The extension of intersection of these two straight lines, these two lines, is the eye center, that is 2, 4 is the eye center. So how many eye centers are observed here? 1, 2, 1 4, 2 3, 3 4, 2 4 and 1 3. Among 1 2 1 4 comes under the category of fixed link, fixed eye centers. Fixed eye centers. 2 3 3 4 comes under the category of permanent eye centers. Finally, 2 4 and 1 3 comes under the category of neither fixed nor permanent NFNP category. So these are the three types of three types of eye centers. So in examinations asks question like that, explain the classification of eye centers with a valid example. So you have to consider this 4-bar chain mechanism and locate the eye centers, and you have to mention what is permanent eye centers, what is fixed eye center, what is a permanent eye center, and what are the neither fixed nor permanent eye centers. So one more important concept in this eye center is that some of the eye centers we can locate by inspection, by visual observation we can locate. Those are first two types. What are they? Fixed eye centers can be located directly, and also permanent eye centers can be located directly. But whereas neither fixed nor permanent eye centers can be located by using Arnold Kennedy's theorem. So the way it seems, how to locate, how can we know these combinations? I13, I24, how can we know? We can know these combinations with the help of another method. That method is circle method. So in that we can understand completely, or rectangle method also. Here in this slide, the convenient way, 1 2 3 4, 0.1, 0.2, 0.3, 0.4, we have to follow in a clockwise location. Mark this 1 2 3 4 represents the number of link. Link 1, link 2, link 3, link 4. Join this link 1 2 3 4. Okay. And eye center, this 1 and 2, 1 2, I12 is the one of the eye center, 2 3 another eye center, 3 4 another eye center, I14 is another eye center. Now you join the diagonals 1 3, I13 is another eye center. This I13 I am drawing here, 1 2 3 4, I13 comes by extending a line, by extending the eye centers of 1 2 and 2 3 straight line. And 1 4 3 4 straight line. That intersection gives the eye center of 1 3. So simple. Which one we have to extend? Which eye centers? In before slides, we have extended 2 eye centers because 1 2 3, these 3 links are rotating in relation to each other. Then their eye center lies on a straight line. But if we want to locate the point, we need both x and y coordinates intersect at one point, coordinates. So we know that one coordinate 1 2 2 3 is the one of the line. What about another eye center line? Now we are assuming that 1, 4, 3 is relatively rotating each other. These three links, that eye center also lies on a straight line. But what are the eye centers are? The eye centers are 1, 4, 3, 4. If we join and extend line, straight line, that intersection gives 1, 3. This I1, 3 is the common eye center. Common eye center means the combination. It comes from links 1, 2, 3 and 1, 4, 3. Links 1, 2, 3, 1, 4, 3 joining. Then the common eye center comes. What is the common point, sir? 1, 2, 3 is 1, 3. 1, 4, 3 is 1, 3. This I1, 3 comes. Okay, I1, 4 and 3, 4. So 1, 3. Next, suppose another eye center comes, that is 2, 4. How it comes to 2, 4? Again 1, 2, 3, 4. Join 2, 4. This 2, 4 eye center 2, 4 is comes from again links 1, 2, 1, 4. If we extend both eye centers, and 3, 4 and 3, 2 if we extend, we will get the common location of eye center, that is 2, 4. So we got to know this, what are eye centers are. But what are again I am asking another question. From this figure B, we can locate the unknown centers. But what are the eye centers are? The eye centers can be known from the figure C. How many types of eye centers are obtained or can be applicable or can be observed from each mechanism based on the number of links. Now we considered in this figure C 1, 2, 3, 4 link. The combinations 1, 2 and 1, 3 and 1, 4. One is having a combination 1, 2, 1, 3 and 1, 4. 2, 3, 2, 4, 3, 4. How many are there? 3 plus 3, 6. These are the 6 eye center for 4-bar mechanism. So by visual inspection from a 4-bar mechanism, some of the eye centers can be directly located. What are the eye centers are? Those eye centers are fixed eye centers, and another one is permanent eye centers. These two categories can be located directly on the mechanism. Let us see. Here, as I told you here, this is a 4-bar mechanism. So link 1 is fixed link 1, 2, 3, 4. 1, 2. This is I1, 2 and this is 2, 3 and it is 3, 4 and it is 1, 4. You mark it 1, 2. Yes, circle. Next 2, 3. Circle here. 3, 4. Circle here. 1, 4. Circle here. What are the remaining 2 links are? Remaining eye centers are 1, 3, 2, 4. How can we obtain 1, 3, 3, 4? 1, 2, 1, 3 and 2, 4? By using this figure B. 1, 3, 1 and 3. How to 1 and 3 is obtained? 1 and 3 is obtained the combination of 1, 2, 2, 3 you extend. This is 1, 2 and 2, 3. Extend the straight line, extend the line. Next, another combination is 1, 2, 2, 3 is over. Next, 3, 4 and 1, 4. This is 1, 4 eye center. This is 3, 4. Extend these two eye centers. This is intersection. That intersection gives what? 1, 3. Now I1, 3 also located. Next, what is left? 2, 4. Join a 2 and 4 link. This is the diagonal 2, 4. 2, 4 is how it comes to 2, 4 is the intersection of 4 eye centers. 3, 2, 3, 4 you extend. Where is 3, 2 and 3, 4? This is the line. This is 3, 2 or 2, 3. This is 3, 4. You extend the line. Next, one more combination. 1, 2, 1, 4. This is 1, 4 and it is 1, 2. Extend. That eye center is, what is that eye center is? 2, 4. Now I 2, 4 is located. Now all eye centers are located. Okay, this is very important method in order to find out what are the types of eye centers are and what are the combination of eye centers, and from this figure B we can find out how to identify the unknown eye centers which are neither fixed nor permanent eye centers. So very important, by using this diagram we can find out. Okay, permanent eye centers can be found, neither fixed eye centers also can be observed, and also neither fixed nor permanent eye centers can also be located on any type of mechanism. But we understood or we studied with the help of 4-bar mechanism. So in this class we have studied what are the types of, what is description of eye center, what are the notation of eye center, what are the types of eye centers, and what is the theorem which is useful to locate the eye center, that is Arnold Kenneths theorem, and how to find out and how to locate the types of eye centers for a given mechanism. Here the mechanism considered is 4-bar mechanism. In that we located fixed eye centers, permanent eye centers, and neither fixed nor permanent eye centers. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.